Calc BC 4-2 office hours. So this is the assignment. We got some conversion problems first, going from rectangular to polar, and then polar to rectangular for the other ones. So the main relationships that we need to use, which you might try and write down from memory, at least once per assignment, x squared plus y squared equals r squared. They come from this basic idea, xy coordinate, right? And then we do the radius and theta. So you get this little right triangle right here. So if you forget them, you could always do it again. This is just based off Pythagorean theorem. If you want the x from r and theta, x equals, it'd be a cosine of theta equals x over r. You multiply both sides by r, so r cosine theta, y equals r sine theta. And so then r equals the square root of x squared plus y squared, and theta equals the inverse tangent of y over x. So those are those basic relationships. So first one, these are your x and y values. So r is going to equal the square root of 1 squared plus x squared plus y squared. So the square root of 4 is 2. And the angle, you say, well, tangent theta equals opposite y over x. Get these is over 2. Try and do these without a calculator. So, and does tangent equal root 3 over 2? And so this is sine over cosine, right? So that would have to be reference angle of pi over 3, and could be quadrant 1 or quadrant 3, where they're both negative. But this is clearly quadrant 1. Positive x, positive y. So it's gotta be pi over 3. So you have the radius, and you have the angle. It's always radius first, angle second. Now, you could also write this other ways. I mean, if you just think of it, there are other answers. You could do 2 negative 5 pi over 3, go backwards. You could add pi to this. You do negative 2 4 pi over 3. So you should be able to get some other values. So let's see if we can get a negative radius for each one of these. Okay, at least 2 answers, one with positive radius, one with a negative radius. Okay, so here r equals, that's going to be 4 times 3 is 12, plus 4 is square root of 16 is 4. That's radius. Tangent theta equals opposite y over adjacent. So we could reduce that and think of it as sine over cosine. So alpha equals pi over 6, and quadrant 2, or sine is positive, cosine is negative, or quadrant 4. Now this is to the right and down. This is quadrant 4. Definitely quadrant 4. So the radius is 4. Quadrant 4 would be, let's see, 11 pi over 6. We could also do a negative radius. If you add or take away pi from this will put you on the opposite side of the circle, and then a negative radius would give you the same answer. So, I mean, if you just take pi away from that, 5 pi over 6. Be another nice one. Same thing. So here, radius equals 0 plus 4 equals the square root of 4 is 2. Tangent equals opposite over adjacent. So when is cosine? So I mean, sine can be whatever. When's cosine 0? So that's got to be at pi over 2 or 3 pi over 2. So think about this. This is straight up. That's got to be pi over 2. So that's going to be 2 pi over 2. a negative radius could be, we could add pi to that and get to 3 pi over 2, and then do a negative radius. Same point. I mean, there's other answers you could put too, but let's see, let's make sure. Oh, you know what? I messed up. This is downward, so it should have been 3 pi over 2. 3 pi over 2. So then the regular pi over 2. I don't know. I was trying to figure out where we were at. 0, negative 2 is down here. That's got to be that 3 pi over 2 angle. Okay. Next one, r equals 9 plus 9 times 3 is 27 equals 36 equals 6. Tangent equals y over x, opposite over adjacent. Simplify it. Which I think is fraction of sine and cosine. So it's going to be pi over 3. It's going to be quadrant 2 or quadrant 4. This is to the left and up. This is definitely quadrant 2. So the answer is going to be 6. Quadrant 2 would be 2 pi over 3. You could do negative radius, add pi to get to the opposite side of the circle, 5 pi over 3. So there you go. Some quick ones. All right. These ones are the other way. This is your r and theta, and you're trying to get the other one. So these ones are just going to use those formulas. You're just trying to get x and y. So x equals r cosine theta, y equals r sine theta. We use that a ton. So 4 root 2 times cosine of 3 pi over 4. It's going to be 4 root 2. It's going to be root 2 over 2. It's a second quadrant, so it's negative. So it's going to be 2 times, it's going to be negative 8 thirds for the x value, unless I messed up. Let's see. Oh, wait. Sorry. Why did I put root 2 over 3? It's root 2 over 2. It's going to be negative 4. That's your x value. Your y value it's going to be root 2 over 2. Quadrant 2 is going to be positive. So root 2 times root 2 is 2 over 2 is 2 is 4. So that's your y value. So negative 4, 4. Next one, x equals r cosine theta. So negative 6 times cosine of negative 5 pi over 6. And y is going to equal r sine theta. So, I mean, you just memorize those formulas. We're going to use them a ton. So, same thing at negative 5 pi over 6. This is a reference angle of pi over 6. For cosine, that's going to be root 3 over 2. This is in quadrant 3, so it's going to be negative. And so you're going to get 3 root 3 positive for your x. Y, it's going to be 1/2. Quadrant 3 is negative, so it's going to be positive 3. So hopefully you're good at your basic trig. That'll help out. Okay, x equals r cosine theta, which is going to be 0 times cosine of negative pi, which I don't think it really matters. It's going to be 0, but cosine negative pi is same as cosine of pi is negative 1 is 0. And y equals r sine theta. Don't think it's going to matter. It's got 0 multiplying something. It's going to be 0. But there's the work. 0, 0. Now, these ones we can't write multiple answers. This is xy coordinates. There's only one xy coordinate pair that'll get you to one location. Okay, last one of these. So cosine pi over 3 is 1/2, pi over 6, pi over 4, pi over 2, pi over 3, 1, root 3 over 2, root 2 over 2, 1/2. It is in quadrant 1, so it's positive. Sine pi over 3 is root 3 over 2. It's going to be 6 root 3. So it's going to be 6 root 3. There you go. Okay. Now for some graphs. So this one, I don't think you need to make a table for. This is a really simple circle. It has just a restriction that r has to be 3 no matter what for any angle. Well, 0 to 2 pi, which would be the whole circle. And I think I want you to show me where it starts and ends. Give me rectangular coordinates. You can show me the direction. I think it's graphed. Okay. Number 11. Now, if you recognize these ones, if they just have sine or cosine, there's no number being added. That's a circle also. And it might be good to remember that, but then you could always just make a quick table. And this will help you make sure you don't, because they can get tweaked a little bit where they're now anything with sine should be vertical in orientation, so it should be up down. But we'll just plug in some values real quick. So 0, 2, 0, -2, 0. So I think we could go with 1, 2, -1, -2, 1, 2. Make the graphs bigger if possible, just to, 0, 0 starts here, and it goes up here, and it goes back down here. And these circles, they only need 0 to pi. So 0 to 2 pi is redundant. It just gives you the same shape over again. So this is that circle. It's vertical. And so it starts and ends here. And the direction is this way. And it is a circle. It repeats itself twice. So, okay, next one. Probably should be a circle. Probably should look sideways. It has a name front, so that's going to have a certain effect on it. But like I said, I don't think it's critical. It's good that it's a circle and then it's going to be oriented horizontally, and that the diameter is going to be 2. So that's going to be -2, 0, +2, 0, -2. So we're going to go with that. So 0, -2. The angle is pointing to the right, but the radius is negative, so it's going to be over here. And then pi over 2 is going to be up here with a 0. And then pi would be over here, but it has a positive radius, so it repeats. It's right on top of itself. So you can just put a couple other dots right there so your drawing looks nice. And it started actually over here and ended there. And it was going in. That's an interesting question, in which direction it is going. So, I mean, you could do, say, pi over 3, give you 1/2, give you -1. So pi over 3 would be over here and it'd be -1. So that's the next one. So it's going this way. So circle has a radius of 1, and it does repeat itself twice, and show the direction on the graph. So that's all kind of stuff I'm looking for notes of. Okay, next one is a circle with a constant radius of 2. So I'm going to sketch that roughly first, like lightly, like a light dash line, because there is a restriction on the angle. So it's not going to be the whole circle necessarily. It's going from pi over 2, which is right here, to pi. So it's really just going to be this portion of the graph. And it starts pi over 2, so it starts there and it goes in that direction. So it starts here and it ends here. So kind of interesting. So it's a quarter of a circle with a radius of 2. Okay, next one. So next one, there's all the radii between -2 and 3, which you're going to want to go up to pause. You probably want to just do a quick sketch of circles, the rates of 2 and 3, but lightly. So I'm just going to do that because it's going to be a portion of these. So you got that circle, the radius of 2, and you have that circle with the radius of 3. And you're going from pi over 4, which is here, right, to pi over 2, which is here. But notice that the radius is between -2 and -3. So we start here at pi over 4, but we start backwards, right? And then we go all the way to pi over 2, but it's at -2, all the way to -3. So it's this shaded region, this piece of like a donut. And they're solid dots because it's or equals to. So you put a nice dark, thick line on the edges also. Otherwise, it seems like maybe the boundary is not inclusive. I don't know. This is like a eighth. Eighth of like a washer or something. If you want to think back to Calc AB shapes, anyways, something like that. The direction starts here and it goes that way. So, okay. And then r equals theta. Well, 0, 0. Pi over 2 would be 1.7, 1.5 or something. Pi would be pi. This is the Archimedes spiral. We did that in the notes previous lesson. So as the angle gets bigger, the radius gets bigger. And when you're at 2 pi, you're going to be all the way over here. You got 3 pi over 2, you're going to be at like 4 point something like that. So it's going to kind of look like this. It's going to keep going. And technically it involves all the negative angles. So it's going to be the other half of 2. It's going to be this whole thing. It doesn't really start or end anywhere. So it kind of looks like that. It's the whole thing. Well, no, actually, sorry. I guess at this point we would refer back to the directions that said 0 to 2 pi. So it would just be, if that were the case, it would stop right here, start here. That's the direction. The end here. If it's just 0 to 2 pi. So. Now, these ones might be kind of hard to remember. Like, these are the cardioids, the lemmasons, actually. Cardioids are one of those. This is not a cardioid because the numbers aren't the same. It's going to be horizontal in nature. I would just, some of them are cardioids if the numbers are equal. Some of them have an inner loop, which will be obvious. Some of them are kind of pushed outwards, which I think will be obvious once you just calculate a few values. So I'm just going to calculate a few values. And if you look, that's going to be 3, 2, 1, 2, 3. So 0, 3 starts here, and then pi over 2, 2 is there, and then pi is going to be at 1, and that's usually where we get that cusp on a cardioid, or if it's an inner loop, it's going to be inside 3 pi over 2, 2. So I think this is like a convex limacon. So it's kind of like a circle. It's been kind of smashed in on one side. So, and I didn't memorize that. I was just kind of going off of what I got. Now, limacons, they have a little curly tail on the C. I forget. It's like a special name for that. So it starts and ends here at 3, 0. This is the direction. And it's just once, you just see the shape once. Okay, next one. Now, the next one I think is going to be a cardioid of some type because the numbers are the same. The negatives have a certain effect on it, but the shape should be the same. It's just going to should be up and down because of the sign. So, I mean, this should be a cardioid. So I'm going to do a quick table. And if you plug 0 in, it's going to get -1, pi over 2. You get -2 pi, you get -1. 3 pi over 2, you're going to get 0. 2 pi, it's going to be back to -1. So probably make your graph look bigger. I mean, the biggest radius looks like it's 2. All right, so 0, -1, facing right, but you have -1 radius. Pi over 2, -2 is going to be down here. Pi is going to be this way, but with a negative radius going to be backwards. 3 pi over 2 is down here, but it has radius at 0, and then 2 pi back, -1. So you're starting here, and you're going this way. So that's the direction. This is where you start and end. So nice quick sketch. Okay, now for the rose curves, which I don't know how many of these I'll do. So there's some quick things on these. One, they're going to fit inside a circle that has a radius of the number in front of them. So I would sketch that first. Okay, all right, one. It's the first thing I would do. Sketch a circle. And it's going to help you, it's going to make it easier to graph. And it's going to make your picture come out a lot better now. This is not part of your graph. You can leave it, just make it light and dashed. Okay? Then you might want to figure out, well, how many petals does it have? So it has a radius of 1. And how many petals does it have? Well, if it's even number, and you're going 0 to 2 pi, it's going to have 4 petals. You're going to double the number of petals. If it's even, if it's odd, you can have that number of odd, because the second set of petals on the odd ones are right on top of the first set. So even though there are 6 petals, the second 3 petals are right on top of the first 3 petals, and you can't tell. But on the even ones, you can. So then the other thing to look for, I don't make a table for these. I look for where's the tips of the petals. And so I set the radius equal to plus or minus the amplitude, extreme radius. I say, okay, well, 1 to sine equal 1 or -1. That'd be pi over 2 plus pi k. So then theta equals pi over 4 plus pi over 2k. And so theta equals pi over 4. 3 pi over 4, 5 pi over 4, 7 pi over 4. So that's where all the tips of the petals are. So I'm going to sketch those angles in pi over 4, 3 pi over 4, and usually you just want to extend it all the way through. Because in this case, it actually ends up being these other petals. And you want to draw the angles exactly halfway between those ones, which happen to be the axis. Because they're going to be the edges between where one petal starts and another one ends. So if you plug 0 in here, you can get 0. So that's where it starts. And you're going to hit that first petal right here at pi over 4 with a positive radius, because that's that first extreme value. So it looks like this. And you might go ahead and put the other tips of the petals there. That's the first petal. Then it goes into this second petal, which has a negative radius, because sine then gives you a -1. Second petal, third petal, fourth petal. So it starts there. This is the direction. Starts and ends at 0, 0. You get the whole shape. I don't care about the symmetry. That's fine. You use your calculator to confirm this, all of these. So that's why I'm not giving you guys the answers. Sine to theta. And we got a window, 0 to pi. We could probably say like -2 to 2, -2 to 2. Even can make it even smaller. A window. We know it should fit in a circle radius of 1. So there it is, there it is, there it is. It's kind of more like a 4-leaf clover. But even you can see it graphing it, watch it graph it and see which petals get. I want the petals numbered. Okay. Now, next one has a radius of 1, whatever the number in front is. So we're going to do a quick sketch of that circle that it will fit inside of lightly. Okay. Now, this one should have 3 petals because the second set of petals will be on top of the first set of petals. Let's figure out what the tips of the petals are. Set the radius equal to plus or minus the radius of the circle. And so then when does sine equal plus or minus 1? Pi over 2 plus pi k, pi over 6 plus pi over 3k. So we could just do the first 3 angles, pi over 6 plus 2 pi over 2 plus 2 pi over 6, 3 pi over 6, 5 pi over 6. So pi over, okay, so usually I get like, try and get the, now to get pi over 6, I usually sketch pi over 3, which is going to help us anyways too. So that's pi over 3, right? And this is where pi over 6 comes in. And I'll draw all the way through. This is pi over 2. And then 5 pi over 6. It cuts those angles, those other angles. So there's 5 pi over 6. So the first angle, the first tip is at pi over 6. It's right here. It's positive. And the next one's at pi over 2, but it's negative. So it ends up down here. So here's your first petal. This is going to be your second petal. And then your third petal is going to be at 5 pi over 6, which is going to be positive 1 again. So this is going to be your third petal. So it goes like this. It goes like that. And the angles that cut exactly halfway between the different tips should be the boundaries of these petals. And then it goes smoothly into this next one. And then it goes smoothly into the next one. And then it goes smoothly back into the beginning. So that's what it looks like. It starts and ends at 0, 0. And the direction is like this. And it gets repeated twice if you go 0 to 2 pi. Because that only takes 0 to pi to graph that first one. Next one. The radius is equal to 2. It's going to have 8 petals because it's an even number, so it's going to be double. So we should sketch the circle that it will fit perfectly inside of first, which will make your graph look better for sure. And it should make it easier to draw it. Okay. Then we got to figure out what the tips of the petals are. So plus or minus 2 equals 2 sine 4 theta, okay, which becomes plus or minus 1 equals sine 4 theta. And so then 4 theta equals pi over 2 plus pi k. And then theta equals pi over 8 plus pi over 4k. And I think we could actually get away without listing all the angles because I think this is enough information. So if you want pi over 8, I would do pi over 4 first because that's easier. That's that 45-degree angle. It cuts those out. That's pi over 4. And pi over 8 would be here, right? And then the next one would be 2 pi over 8 would be right here. And the next one would be here. The next one would be here. And I would draw them all the way through. So the first one's at pi over 8, and it's positive, so it's right there. The next one's at 3 pi over 8, it's going to be negative, it's going to be back here. So here's the first petal, Here's the second petal. And then we're going to go to add another 2 pi rate to 3 pi rate. It's going to be 5 pi rate. It's going to be here. It's going to be a positive one now because it alternates. It goes positive, negative, positive. It's the third one. And then the next one's going to be here, but it's going to be negative. So it's going to be back here. That's the fourth one. And then the next one's going to be here. It's going to be positive. So that's the fifth one. The next one's going to be here where we were already at. That's going to be that's going to be negative, so it's going to put it back here. So it's going to be sixth petal. And then the next one's going to be here. It's going to be positive, so that's the seventh petal. And then the next one's going to be here, but it's going to be negative, so it's going to be back here. This is the eighth petal. Now it should work really smoothly. I mean, this one's kind of a pain, but this is the first petal, and it goes nicely, perfectly into the second petal. It goes nicely and perfectly into the third petal. It goes nicely and perfectly into the fourth petal. It goes nicely and perfectly into the fifth petal, sixth petal, seventh petal, eighth petal. Wow. It starts and ends at 0, 0. They don't all start and end at 0, 0, by the way. The direction is like this. And it's this nice smooth one to the other. So I'll try and do a couple more of these. Might run out of time, and you could look at my work, but you should be getting the hang of this. So the radius is 2. There are 5 petals because it's odd. So we're going to sketch the circle, the radius of 2, that it should fit perfectly within. And then we got to find those angles of where the tips are. I think that's your best bet. It's easier making a table and just kind of like stumbling upon them. So I'm trying to be very purposeful here. So it's going to be pi over 2 plus pi k. So it's going to be pi over 10 plus pi over 5k. Okay, so the tips. So pi over 10 plus 2 pi over 10k. So the first one's at pi over 10. Okay, this is pi. This would be pi over 2, so pi over 10 would be a fifth of this. This one's kind of a 9. Maybe like that. And then I think we're going to just want pi over 10, 2 pi over 10 because we want the angles, 3 pi over 10, 4 pi over 10, 5 pi over 10. Oh, sorry. 1, 2, 3, 4. 5 pi over 10 would be right here. This is not great. Okay. And then we keep going. Okay. First angle is positive. Next one is negative. Next one is positive. Next one is negative. Next one is positive. That should be it. So the first one is right here. And the second one is over here. And then this is the third one. This is the fourth one. And this is the fifth one. So 1, 2, 3, 4, 5. And I'm going to want to know for sure that you knew what those angles are. So probably might want to at least label those angles as pi over 10. This is 3 pi over 10, 5 pi over 10, 1/2, 7 pi over 10, 9 pi over 10. So again, starts and ends at 0, 0. The next one won't. Just in case you thought, no, I thought you said that's the direction. Okay, next one is cosine. You'll notice if you look at this one, it definitely has a vertical orientation to it, like a symmetry left to right. This one should have a horizontal symmetry or horizontal orientation with a kind of vertical symmetry, top to bottom, bottom to top. It's going to have 3 petals. It's odd. Or even, you double it. It has a radius of 1. Okay, so first step is to sketch rough, quick, light circle that fits light dashed. Okay. Then we say, all right, plus or minus 1 equals cosine 3 theta. So 3 theta equals 0 plus pi k. So theta equals 0 plus pi over 3k. So 0, pi over 3, 2 pi over 3. We're going to probably want the angles in between them. So that'd be the pi over 6 angles, those. So pi over 3 is going to be where the first one is now. The first one's at 0. It has a positive, and then pi over 3 is going to be negative. It's going to be back here. And then the third one is going to be at 2 pi over 3 positive. And then they're going to just end up repeating themselves. So technically, it starts at like the halfway point of the petal, goes smoothly into this one, and actually finishes the first petal at the end. So it starts and ends at the tip of the petal here at 1, 0. And the direction goes like that. And sure enough, it has a horizontal kind of orientation to it, right? Symmetry, top to bottom. Okay, do one more. This is going to have a radius of 1. It's going to have 4 petals. It's going to look left to right, horizontal orientation. So we could sketch the radius first with a simple rough light circle that our shape should fit perfectly in. If you don't do that, I'm going to really scrutinize your thing by drawing one myself, and some of your tips are going to go beyond it, and some aren't going to be long enough. It's not going to look good. Draw this first. We got to figure out those angles where the flower tips, the petals are. So it's going to be 0 plus pi k. That equals 0 plus pi over 2k. So 0, pi over 2, pi, 3 pi over 2, and then cut those angles in half because that's where it's going to go through the pole, and those are going to be edges of your petal. So here's the first petal. It starts at 1 because cosine's positive 1. And it goes like this, and then it goes into the second petal down here smoothly. Nice. And then it goes into the third one over here. And then it goes into the fourth one at the top. And then it actually finishes the first one. So starts and ends at 1, 0. Direction is that way. My pen is running out of ink. But that's it. I mean, they're kind of a bit of work, but you kind of get the hang of them. Hopefully there's not too many petals. So generalize these rules. So if n is odd, number of petals equals n. If n is even, number of petals is 2n. The pattern created. Don't worry about symmetry. I mean, you figure it out. But this is going to have sort of a vertical orientation to it. This is going to have a horizontal orientation to it. And that's true for all these different polar shapes that involve trig. The pattern, when it's an odd number, it's repeated twice. When it's an even number, it's repeated once. So, anyways, there you go.